Hello all. Today I am going to start my day 1 class. Day 1. In day 1, I am going to teach you about the addressing. So, addressing is required, or you can say the address is required to communicate two or more people's points together, and they can easily identify to neighbor, or you can say the remote person. So I am giving you one real example that one person this calls the name is John. Second person the name is Lucy. So if you see the John, this is the human, but identification required the one name. This is the lady, and the requirement of the one name to identify this. So if John want to communicate with Lucy, then John required the Lucy name, and if Lucy want to communicate, then Lucy required the John name. If they are going to share anything to anyone, then they will send by the name hey Lucy. Suppose the John want to communicate, so John will start hey Lucy, I need something. Or if Lucy is going to reply, then Lucy will start John, yes I am doing this. So address is required to identify that person. So in real scenario, if you see the post, you are sending something by the post, so you are putting the all address to John and something like that. This is the address 8 8 12 address area something area 2 and like that, and then the Lucy will send the post to John, and John is going to receive. So if you see here, there is the two address contain. One that is the name calls the logical address, and one that where the John is stay, that is the permanent address, or you can say that is the physical address. Physical address is required because the then your postman or something who is going to deliver your post, they will identify John will stay in this area, in this apartment, and this floor. Then they are going to deliver it. Same patterns, if you are going to see in the network also, there is two different things in the addressing. One that is called the physical address, one that's called the physical address, and one that is called the logical address. One that is called the logical address. Logical address. In physical address in the computer, if you will go there, in the computer physical address called the MAC address. MAC address, that means media access control. It's a full form, that's a media access control. Simple. In the media access control. In media access control. Control. So physical address work on the layer 2, and logical address will work on the 3. We'll discuss about the layers in the when I will start OSI model, or you can say the TCP/IP model. So the MAC address is defined in the 48 bit and in the hexadecimal. If you, I, I hope that you are understood the physical address and the hexadecimal. So as you know, the hexadecimal, if I am going to just little bit explain it, hexadecimal is total containing the 16 digits. digits, and its 16 digit can be numerical or the alphabet. So the hexadecimal defined in the mix. So the numeric can be between 0 to 9 and alphabet can be between A to F. Anything. So total number, you can say a total digit, it's called the 16 digit. And hexadecimal, each digit is going to use 4-bit space of memory. Simple. That is the 4-bit space of memory. And similarly, if you talk about the binary, because we are going to use these two formats, binary and the hexadecimal in the addressing part. So in the binary, there will be the two value, that 0 and 1. So sometimes people are saying to 0 that is the off bit or that is the false bit. And for 1, the peoples are saying that is on bit, or sometimes peoples are saying that is the true bit. So these two value going to use in the binary, and in the hexadecimal, if you are going to use that, you will see that 0 to 9 and A to F. So if I am going to describe your physical address, so physical address totally defined in the 48 bit. So 48 bit, your physical address is defined in the 48 bit, and 48 bit equally divide into 6 octet. So octet, that means every octet have 8-bit value. So if you will see that the lowest value is the 0 and highest value is F, and every octet you are going to use, if I am just putting here this, so I am just divided into 6 octet. So that will be the 1 octet, that will be the 2 octet, that will be the 3 octet, 4 octet, 1 2 3 4 5, and one more, that is the 6 octet. So each octet, either value can be 0 or maximum can be F. So as already I told you that this is divided into 6 equal octet, and the maximum in the 1 octet you can use the 8. So in the 1 octet you can maximum use the 2 digit of hexadecimal, because each octet going to use 4-bit value. So if you will see, I can use the maximum 8-bit value here. 8-bit, 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 and 8-bit, and 8 bits. 8 bits value total. Maximum I can use in the 1 octet, that with 8 bits. So if I can say that the minimum I can use 0 0 0 0 0 0 0 0 and 0 0. Maximum I can use F F F F F F and F F F F and F F. So this is the last MAC address, and this is the first. So this is the called, some people call the invalid MAC address, or some people call the multiple things about the 0.0.0. But in the F, if you see, this is the last MAC address, so it's called the broadcast MAC address. Broadcast MAC address. So if I'm just talking about the layer 2 communication, so suppose this is your PC1, this is your PC2, this is your PC4, and this is your PC5. So I am just going to connect by the one switch, and it's going to connect like that. So this is the port 4, this is the port 3, this is the port 1, and this is the port 2. So once you connect your system, it is going to broadcast to search his neighbor. So they are going to broadcast. If you see here, if you see here, so just if you see here, your system is going to broadcast on this address. So they will send one L2 packet with this address FFF, and they are going to send on the every port. So this will be the individual MAC address. So they will send, and then once they are going to reply back, they will give the actual MAC address. So based on that, they are going to maintain the ARC table. You can say that is the ARC table. So they are going to maintain that which system is connecting on where, and same times your switch is going to maintain one that is called the MAC table. So MAC table will contain, suppose just I am giving you the example that this MAC address A1, A2, A3, A4 and A5 and A6. This is the MAC address 1, 2, 3, 4, 5, 6. So this is the MAC address. Suppose I am going to tell this B1, B2, B3, B4, B5 and B6. Similarly, I am going to C1, C2, C3, 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 C4, C5 and C6. So this is the MAC address. This is the MAC address. Same, I am going to here that I can say that is the D1, D2, D3, D4, D5 and that's called D6. This switch is going to maintain one table for port number 1. It's maintaining D1, D2, D2, D3, D4, D5 and D6. Port number 2 will maintain port number 2 A1, A2, A3, A4, A5 and A6. Here it will be D6. So similarly they are going to maintain the 4 and 5. So your switch, because this is the layer 2 switch, so they know because of they are maintaining the MAC table. So once the packet will come from the A1, this MAC address for the AD1, that is going to directly deliver on this. They are not going to send the broadcast, because in the when you connected your laptop, they sending the broadcast address, and based on that they are containing also his MAC address in the source. They are going to maintain in the table. Based on that your switch is going to send. So like that your system is going to maintain the physical address if that is communicating in the L2. But when if this information going over the L3, then you require your logical address L3, then your system is required the logical address. We'll discuss later. So I hope you understood that how MAC address working. So if this is my Windows system, I am going to show you how you can see your MAC address. So you'll see. So there is the one command. You can check get MAC. Get MAC is showing your how many your interface is connected and what is the MAC address. So if you will see in the my system, if you will see here, in the my system, in the my system, if you see, that is the connected 1 MAC address, 2 MAC address, 3 MAC address, 4 MAC address, 5 MAC address. That means in the my system, this is the my system, they have connected the 5 physical, or you can say that is the LAN port, or you can say that is the interface, network interface, 5 interface in the my system, which is showing the 5 MAC address. So I can use it. Maybe it can be the logical or it can be the physical interface. So also sometimes if you want to see, how I can, just 1 second. So if you see, also you can say, you can check here one more things, like IP config. If you want to see the IP config slash all, so in that every interface, so what is the my MAC address of my Wi-Fi interface, what is the MAC address of my other interface, what is, so based on the interface, if you will see, there will be the MAC address, it will show. And other things, if you want to go ncpa.cpl, that is the your network property, so you will see here inside the, so 1 2 3 4 5 6 7 8 9 10 11, because of that is the some virtual interface that's contained with the my virtual box and the VMware. But if you will see 1 2 3 4 5 interface is enabled, that's why there is the showing the 5 MAC addresses. And if I want to go here in the Wi-Fi interface and I'm just clicking on the details, so also I can see the my MAC address here, whatever actually I check in the network interface. So if you'll see, that is the my MAC address, and if I show here, so AC, A9, AT, C4, CD, D6, this is the my MAC address. So in the interview time, sometimes interviewer giving like that MAC address, so just I'm showing you, maybe they can give you like this. So and they can ask to you, hey, my MAC address is C1 D3 1143 J J0 and L3. So they are going to show you, and they can ask two MAC address, one that is the AB 00 00 00 01 and 10, and they can ask to you, hey, which one is the valid MAC address and which one is not. So you can just see, because you are using the hexadecimal, so in the hexadecimal you can maximum use 8 0 to 9 0 to 9 or A to F. So after, you can't use the any digits, like you can't use the G H I anything, only you can use A to F, because in the hexadecimal only 16 digit is valid. So 16 digit can be 0 to 9 numeric or A to F alphabetical. So you have to see, whenever actually you are going for interview or you are going to troubleshoot, someone is putting the some invalid or someone is giving you some invalid or wrong information, then you have to check one by one and you should troubleshoot it. So I show you that how you can see your MAC address. So in the Windows you can use the get MAC, or you can use the ipconfig space slash all, then you can check your MAC address. Or this is the CLI, and if you want to go in the GNA, go in the your control panel, or you can just put in the run command, that is called the ncpa.cpl, and after that you go in the that property, that interface properties, which one you want to see the MAC address. So this is the all about the MAC address, that what is the MAC address, how many bits they are using, which format they are using. This is the hexadecimal. So also one more things I want to highlight. So there is the two valid format for the your MAC address. One, it can be are the 6 octet, or it can be in the 3 octet. If they are going to use the 6 octet, one octet will be the maximum 8 bits, and if they are going to use 3 octet, it can be the 16 bits. So I am just giving you the two example for both. So if I am going to use the 6 octet, then how I can write 1105 A1 CD F3 F3 and 1, you can say like B. So this is the 3 and 3, that is the 6 octet. So if you will see the in the 1 octet, I am using the 2 digits. So 2 digits. So in the hexadecimal, 1 digit is using the 4 bit. So I am using the 2 digits. That means 2 into 4 equal to 8 bit. So I have used the 2 bits of each. So 1 bit is using the 1 digit is using the 4 bit. So it's a 8 bit value. Either you can write this or you can write this 1 same. I am just going to use this A1 CD dot dot and F3 18. So either this is the valid format or this is the valid format. You can't write like 110 5A1 CDF 318 or B. You can say that is the B. That is the B. So you can't write your MAC address like that, because this is the not valid. So which one is the valid? This one is the valid and this one is the valid. So whenever you are going to troubleshoot or you are going to give the example, if they are asking to you about the valid MAC address format, then you have to care about that which one is the valid and which one is not. Maximum, it can be used the 48 bit. MAC address will be right in the hexadecimal. In the hexadecimal, one digit is going to use 4 bits value. So maximum, how many value can be used? You have to think about. So maximum, the total value will be the 1 2 3 4 5 6 7 8 9 10 11 12, because 1 12 digit you can use. So 12 digit, because 1 digit is using the 4 bit and maximum you can use the 48 bit. So if you are going to use if you are going to divide for your 48 by 4, you will see that means 4 1, and that is the 42. So your remainder is going to 0. So your value is the 12. So 12 digit maximum you can use. So you have to remember these things whenever you are going for your interview, or whenever you are going for your troubleshoot, or for the examination. So how your MAC is working. So if you are asking about the key points, so key points, your MAC address defined in 48 bits. It's using the hexadecimal. Maximum you can use the 12 digits, and it's a layer 2 protocols. You can say, it's working on the layer 2. So this was, and also the MAC address called the physical address, or sometimes people are saying permanent address. So you have to remember that is the what is the MAC address, what is the physical address, what is the MAC address, which layer it's working, how many bits and how many others. So now I am going to start about the logical address. So it's a logical address. Logical address, it's working on the layer 3. We will discuss later in the during the OSI model. Layer 3. Layer in the logical address in the networking, there is the two versions introduced by the industry. One that's called the IPv4 and one the people are saying the IP version 6. In the IP version 4, this is defined in 32-bit, and IP version 6, it's defined in 128 bits. We are not going to discuss today about the IP version 4. We will discuss later. Today I am going to discuss only about the IP version 4. So this is the 32 bits. And also in the IP version 6, it's defined in the hexadecimal and IP version 4, this is defined in the binary. Simple. So you'll see the IP version 4 defined in 32 bits, and this is going to use the binary, and IP version 4 divide into it's divided into 4 equal octet. So 4 equal octet, it is the divided. So every octet going to use 8 bits, and separated by dot. This is the standard. Yes, some people are sometimes they are using the minus something like this pipe and something for the separation, but the standard this is the separated by dot. So 8 bits, 8 bits and 8 bits. So you'll see the 8 bits, 8 bits and 8 bits. I am just putting in 4 octet. So this is the 4 octet and this is defined in the binary. So if this is defined in the binary, so in the binary I previously discussed that binary is using the two value. It's 0 and 1. So binary using the two value maximum. Either it can be 0 or it can be 1. 0, sometimes people saying the off value and sometimes it's called the false value. 1, that means the on bit and are the true value. So if I am going to see that it's a off value, so it's a minimum. It's the first value. You can just say that is the first value and this is the last value. So if I am going to put in this scenario, so you will see the minimum value, the 0 0 0 1 2 3 4 5 6 7 8 dot 1 2 3 4 5 6 7 8 dot 1 2 2 3 4 5 6 7 8 dot 1 2 3 4 5 6 7 8, and maximum what I can use. The maximum I will use 1 2 3 4 5 6 7 8 dot 1 2 3 4 5 6 7 8 dot 1 2 3 4 5 6 7 8 dot 1 2 3 4 5 6 7 8. So if as previous I told you that the one bit or you can say the one value going to use the one bit, a binary. one digit is going to use one bit. So that's why I put it here 80 because I require the 8 bits, and maximum I can use the 8 ones, or minimum I can use, or maybe sometimes I can use the combine 0 and 1s both. So in same I can show you just that where I can just give me 1 second, I need to extend it. So just I'm extending it. Okay, good. So you'll see, I hope that you know that how you can you can convert the binary to decimal and binary decimal to binary. So binary to decimal and decimal to binary, it's so because as a human we know about the binary, and you know the binary is 0 to 9, sorry, decimal is 0 to 9, binary is 0 to 1. So somehow I have to convert from binary to decimal, and if I want to know that what is the binary value of this decimal, then I have to convert from decimal to binary. So as of now, for example, I will tell you that how you can convert the binary to decimal and decimal to binary, but just I am going to, so for this, if the my 8 bit is going to on, the if my decimal value is going 255, 255, 255 and 255, because my 8 bit is on, or you can say that is the 1. So for example, if I am going to convert it 1 2 3 4 5 6 7 8, so simply 2 power 0, 2 power 1, 2 power 2, 2 power 3, 2 power 4, 2 power 5, 2 power 6 and 2 power 7. Total, that is the 8. If any number have the 0 power, the value will be the 1, and this is the value 2, and just I am going to add this 2 power 2, that means 4, 2 power 3, that means 8, 2 power 4, that means 16, 2 power 6, that means 32, sorry, 2 power 5, that means uh, 32, 2 power 6, that means 64, and 2 power 7, that means 128. If I am going to calculate all this number, the value will be the 255. So simple. That's why I so tell you that if in the one octet you can write minimum 00, maximum 250. So if you'll see from here to here, if I'm going to total calculate in the one octet, maximum I can write the 256 value. So based on this, IP was divided. So IP divided, IP in the class, there was the multiple purpose that when people was divided in the class A, class B, class C, class D and class E. So I am going to tell you that how you can easily this class in the your understanding. You don't need to understand every time or remember the things. You can easily, you require the 2 minutes and you can divide it. So just I am going to take one example, because the your IP classification is going to base on the first octet only. That is not going to use the other octet. Only your first octet is going to classify your IP address in the classes. So if you'll see, you have the total value is the 256, and you need to change, you need to divide your IP address. So just I'm going to, sorry, give me 1 second. I need to just, are you say that, okay. Okay, I can open new paint and I can start. That will be the good things. Not MS Paint. MS Paint. So okay. So I'm telling you, I'm just here. I want to show you how the IP classes is divided. So division of class. So you can say that is the IPv4 class. How the class is divided. So simple and very layman terms I am going to tell you. So see, you have total 256 value, or if I am going to say show you here, I show you that in the one octet you can maximum use the 8 bit, and in the 8 bit maximum you can write the 256. So IP class divided on the base on the your first octet. So sometimes this called the first octet, this called the second octet, this is called the third octet, and this is the called the fourth octet number. So I am going to divide my IP address, or you can say that's in the class based on the first octet. So you see here, so whatever I have 256 address, the how the IP class was divided, so they divide first 50%. If I am going to divide by 2, the my value will be the 128. So here if you go see here, I am just 50%. I am writing here that is the 50%. Control, and I am just write here 50%. So 50% value, if I am going to see, that's I have the 128. So 128, because I am starting from 0 and I need 128, so I have the 127. So range will be the 0 to 127. This called the class A. I will tell you that which is the valid and which is not your valid range from the where to where, but this is the base, that is the class A base. But from where to where people are saying the class A, I tell you. Give me 2 minutes more. So now you have only the 120 array IP, or you can say the digit are all levels. So again the organization was divided this 50% in the two parts. So when they are using like this, so they also divided into two parts again. So they divided into two equal to, if you see, that is the 64. So if I am going to add 64 here, so 64, 1, 6 to 8 and 9 and 1. So your IP will start, because already you end your IP 127. So it will start from 128 to 191. And this is called class B. And this is the total range, that is the 25%. You can say that is the 25%, total range of your 25%. Now I am going to, whatever they have IP address, they divided into two parts. So if you see, that is the 32. So if I am just going to add here 32, so it is the 33, 9, 3, 12 and 112. So my IP will start from the 192, because I have already consumed till 91. So they divided into this like. So total, if I am going to share, there's a 12.5% of total range, and my range will start from 192, sorry, 192 to 223. So this is the range of what? Class C. And now the total of the total 12.5% is the remain, but the organization was divided again into 50-50%. So if I am going to say this is the 6.25 and this is the 6.25 of whole range. So if I am going to again divide it into 2, I have pool of the 16 and 16. So if I am going to add 16 here, you will see the 9, 3 and 2. So my range will start from, because I am still using the 223, so my range will be start 224 to it's 239, and this called the class D, and rest of the IP is for the class E. You can say that is the class E, and my IP address will start from 242 to 255. So this type of mathematical division of your IP classes of IP version 4. But I will just show you how in the your first octet they are divided, but how they divided I told you. So in the class A, if you see that is the start from the 0. So because 0.0.0.0, that is the universal default routing, you can say this is the invalid host, or you can say that is the default route or default network address. That means you cannot use this address. So your IP will start from 1 to 127, and this is the class A. So if I am going to say that what is the class A range, then you can say class A, the 1.x.x.x to 127.x.x.x. This is the valid range of class A. And class B, what is the valid range of class B? So your first octet will start from here 129, 128.x.x.x to till where your first last octet 191 dot x dot x dot x. X, that means what? X, that means it can be from 0 to 255. Any value can be between of that. That means X. And class C. So if I am going to talk about class C, my range will start from 192. If you will see 192.x.x.x to till the 223 223.x.x.x. If you will see the class D, I am just, this is the class C. Class D will start from the 224.x.x.x to 239.x.x.x. And class E start from 240.x.x.x to 255.x.x.x. This is the classes of IP version 4. So class D used for multicast only. So whenever actually you see the IP address of this range, you have to reckon this IP reserved for the multicast. And from 240 to 255, this is the experimental. So you will not able to put this range in your system or your network equipment. So this is the, you can say that the experimental or the government use. So you will only use till here. If you are going to start using for this, it is not going to work, and also you will not able to assign this IP address in your system. So this is the classification of IP address. But now I am going to show you in the here in the binary format how they are going to use. So you'll see this is, I'm just going to show you, this is one for, and just I'm going to divide this like this, and my first IP I'm just divided into 1 octet, second octet, third octet, 4 octet, 1 2 3 4. So sorry, I forget, 1 octet and 2 and 4. So 1 2 3 4. So if you will see the class A, in the class A, the documentation is saying in the class A, the first one bit will be the reserve. In the class A, one bit will be the reserve. So if you see the first IP 0, 1, 2, 3, 4, 5, 6, 7, 8, and it can be the X, it can be the X, it can be the, you can say that is not X, 0, 0, 0, 0, 0, 0, 0, and 4, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, and 8. Maximum can be 1 2 3 4 5 6 7 8, 1 2 3 4 5 6 7 8, 1 2 3 4 5 6 7 8, 1 2 3 4 5 6 7 8. So if you are going about the documentation, so if the documentation is saying in the class A, your first bit will be the result, your first one bit will be reserved. So one bit will, if I am going to reserve it, if I am going to make it 0, so if you are going to calculate this one, so the value will be 127. So I can also show you that 1 2 3 4 5 6 7 8 and 1, that is the 0. So 2.0, 2.1, 2.2, 2.3, 2.4, 2.5, 2.6 and 2.7. Sorry, 1 2 3 4 5 6 7, and that will be the 0, and that will be the 2 ka power 0. This is the 0, not a power, because that is the 0. So 1 2 4 8 16 32 and 64. If you are going to calculate all, the value will be 127. So in one bit, the your first digit was 6. So your first digit was 0. So if you will see your first digit was 0, then your value was 0 to 127. That's why your class A, your valid, your range from 0 to 127. But 0, 0.0.0, it's called the unique network address, or you can say the default network address. So that's why this is not a valid range. So your valid range from 0 to 127. So again, if you are going to start class B, so your all bit is full, so you are going to use next bit. But in the class B, the your this is the going to 1, this is going to 1, this is 0. So in the class B, your 2 bit is going to reserve. So your 2-bit going to reserve. So if you are going to see here, that will be the 0, that will be the 1, that will be the 1. So if you will see, that is going to start from 128, because this range is going to 128. And if this is the 1, so I am just going to convert this binary 1. So just I am giving 1 0 1 1 1 1 1 and 1 3 3 6 2 8. So this is the 1, this is the 2, this is the 4, this is the 8, this is 16, this is 32, this is the 0. So it that doesn't, and this is the 128. So if I am going to total calculate, the value will be 120 191. So your range is from for class B 121 to 191. In the same patterns, just you can follow, and in the now your this bit is going to change in the class C, and your 3-bit will be the reserve. So if you will go here in the 3-bit, the 1 1 and this bit is going to 0. So your range will start from 192, because this is, if you are going to on first 2 bits, your decimal value will be the 192. So that's why your value is going to start from 192. And if you are going to change this, so this value and this value is going to make 223. That's why your class C value 192 to 223. Same in the class D, your 5th digit is going to, your 4 value is going to fix, and your class E, 5th value will be the fix. So same patterns, you can just identify your class dividation, class A to class B. So I need to just explain one more things, and then for the subnetting parts I will discuss in the next class. So in the classes, there was some range that was reserved for private. So if you will see, I tell you that about the class A. Class A, if I am going to show from here, class A. So class A was okay. So class A, the I started from 1 to 127. Class B 128 to 191, and class C from 91 and 210. Class D we can't use class D because this is the multicast, and class E, that is the experimental, or you can use for the science and scientific and others government perspective. So there is the one more concept come in the picture, that is called the IP, public IP range and private range. But you'll see class A range from 1.x.x.x to, you can say, 127.x.x.x. Now there were the 3 things that use that 127.x.x.x, that IP reserved for loopback. You can say that is the loopback address, or sometimes people say that is the link local address, or sometimes people are saying that what is saying, sometimes the address, or you can say that is the logical address. Sometimes people are saying that 127.0.0 it's a logical address. Sometimes people are saying that is loopback addresses. So this is the reserve you can't use. So when the your loopback address is work, once you are going to start your system, maybe you are not connected your physical address, then your interface automatically going to assign one IP from for system that is from the this range. So this range you will not able to use. And also in the class A, one range also that is going for fixed, that is called the private. So also what is the private and private public address? Private, that means this address will not able to communicate from the public devices. So there is the concept you can use. Maybe suppose you have the one laptop and you put the one private IP like the 10.10.10.5 slash 24 bit, or you can say slash 8 8 8. That means we'll talk about later about the slash. So you can say your subnet mask that 0.0.0, because this is the your class A address. So and one that is the your google.com, and they have address suppose like 4.4.4.4. So this is the public address, this is the private address. They are not going to communicate directly. So there is the one concept that is called the NAT. We'll discuss later about the network address translation later, how they are going to translate your private address to public address. But ideally in this scenario, your system will not able to communicate with this network, because this is the range from the private and this is the public. So there will be the one translator. So that's called the net address. So if you see that is the in the class A, that one address range, that's called the loopback address. One, the private range also excluded from this range from 10.x.x.x slash 8 bit. So we'll discuss later about this slash 8. So what is the slash 8? We will discuss. So x, that means 0 to 255, any value can be in this octet. In the second, third and fourth octet can be anything, but your first octet always will be the fix, it will be the 10 always. So from class A, one range was excluded for the private, one range was excluded for your loopback address, and other rest of the IP used for the public communication. So your public communication, only these two range was excluded from class A. So and from class B one range excluded. So 172.16.0.0 to 172.31.255.255. So in the third and fourth octet, if you see that is the x value, so it can be 0 to 255, but the first octet always will be fixed 172, and second octet will be from 16 to 31. So this is the only private range from class B. And from class C, the one range also excluded, and also one range excluded from the class B, that's called the link address, or some people call the API address, automatic private internet protocol addressing, and that was the 169.254.x.x. This range used for APIPA, and this range used for private. And from class C, if you will see, the one range was excluded, that is the 192.168 and that x.x. This is the private, this is the address. So rest of the all IP address, that's called the public address. So if I am going to summarize for private range, so for private IP, so simply I can say that the from class A, you can say class A one range, that is the 10.x.x.x. This is the private. 127.x.x.x. This is the loopback address. Loopback. And class B, that is the one range 172.16.x.x to 172.31.x.x. This is called the private address. And one IP address 169.254.x.x. It's called the APIPA or link address. Sometimes people are saying this is the link address. And class C, one range was excluded 192.168.x.x, and this is called private and reserve IP, and rest of the things that is the public IP. Because we can't use the class D and class E. So this was about the IP address class classification. You can say that how the IP was divided in classes, class A to class D. And next class we will discuss about the CIDR, subnet, and FLSM, VLSM, and more towards the subnetting. This is the all part in the subnetting, but we will discuss about in the next class, that is what is the how the CIDR notation is work, subnet is work, FLSM, VLSM, network address, broadcast address, valid range. We will discuss in the next class. Thank you for watching my video. I hope you enjoy and you learn a lot. Please subscribe my channels, give the feedbacks what I need to improve. Thanks.